I expect that you would have an understanding of these so that you can understand and appreciate some of the cost-saving things that we're going to talk about. So let us first start off with the main thing on the agenda, which is what is the need for IPVPNs. So typically we notice that there are geographically dispersed IP networks that need to be connected for transparent, secure private IP connection. An example would be a company A buys over another company B, and then these two companies' network will have to be integrated in a fashion wherein they can act as if they are on the same private LAN. So they are geographically dispersed in their locations, but you have to treat them as if they're going to be on the same LAN. That is one of the things. And then as companies have grown over the years, the customers have invariably found that it is much more cost effective to buy IP services from the service provider rather than manage everything on their own. If you look at the history of how networks have evolved, you'll notice that a lot of the customers wanted to manage the network on their own, and so that was a very expensive thing. But now you can buy these services from the service providers, and they'll also ensure security. So it's a much better, it's a big cost advantage for both, right? And another motivation for using IPVPNs is the reuse of the service provider hardware. Earlier, the service provider used to build huge networks, but then the extent to which the huge networks were being leveraged were not as much. I mean, it was not cost effective for the service provider as well. We will see how in this particular IPVPN deployment scenario, the service providers are able to reuse a lot of their hardware. They are able to cater to multiple networks to provide this IPVPN service. And the next motivation is QoS, which is one of the most important things for any customer. He's going to pay the money to the service provider based on some QoS, and we have to see how the service provider is going to help him achieve this particular QoS. It's part of the service level agreement. If you see how networks have evolved, earlier there used to be one network which the service providers used to build for ATM alone, another network for frame relay, another network for IP and things like that. A typical example would be a company like AT&T or Verizon. They used to have 3 different networks, and then they used to offer different kinds of services based on the type of technology that was used at the customer premises. But once MPLS came along, there was a move towards a converged solution, which is a single MPLS core. And the service provider immediately used this to provide different, to provide services to different kinds of access technologies, whether it is voice over IP, whether it is Ethernet, whether it is traffic coming from the DSLAM, or whether it is ATM. It doesn't matter. You have one edge switch which could aggregate all this traffic and then send it over one MPLS core. So with one particular network that the service provider built, he could provide different kinds of services to different customers. So this is a huge advantage and cost savings for both. If you go back to the history of how networks used to be built, I mean, let's call this as legacy VPNs, right? This is how AT&T used to build their network. The layer 2 technology that was being used was HEM or frame relay, and they used to build a full mesh topology wherein all the customers belonging to a particular VPN were connected to each other. And there were some of different problems when a new site had to be added. If you see the screen, if a new site had to be added, the new site had to be connected in a full mesh to all other customer routers. So this is a huge burden for the service provider. So this is a typical case where one company buys another company and it has to integrate it as part of its network. But this was how typically networks used to be built out. One of the requirements when you build an IP network based on an ATM frame relay core would be that you have to have a full mesh of the virtual circuits. Every time a new router is added, the new circuits must be provisioned between this router and all of the routers in the core. And the routing also used to be a huge problem for the customers. There used to be large amount of routing traffic if OSPF or ISIS is in the core, because one of the requirements of routing is that everybody should be able to reach everybody else. So whenever there's a new router that is added, there is a significant amount of routing traffic within the network. And the provisioning of circuits is also complex because it is very hard to predict the exact amount of traffic between two routers. Now, when a company buys another company, it is very difficult to predict what kind of traffic that the other company is going to generate, or what kind of new technologies they would adopt, so that the amount of traffic that they're going to generate is going to vary. So it is very difficult to provision this kind of service in the network. There are other ways the different companies tried to provide this service earlier, which is, one of them is this policy-based routing, wherein you would say, just based on some criteria, you do the forwarding of the packets. Basically, what is the idea here? Every customer set belonging to a particular VPN wants to talk to everybody else. So they could define these kind of policies at the edge of the service provider network and say, for all packets coming from this VPN, you just send it across to the particular egress node. But then, since these kind of forwarding is not based on the destination router, but based on some particular QoS, there could be a lot of forwarding loops. I mean, you are not leveraging the power of the routing protocols to prevent these kind of forwarding loops. Not only that, if you have to ensure a particular QoS along the path from the ingress edge node to the egress edge node, every router along the path had to be configured to honor the particular QoS. So this is a very cumbersome and problematic scenario for the service providers. So in summary, some of the issues that the legacy VPNs had were that the existing service architecture limits the carrier's ability to expand into the growing advanced IP services market. So once IP services evolved, the service providers were not able to leverage that as much as they would have liked, because they were building different kinds of networks with different technologies. So multiple architectures required for layer 2 and layer 3 services. You had to buy different kinds of equipment as well. And depending on the access technology that is being used by the VPN customers, there used to be only one single access technology per VPN. An example would be a service provider would be using, say, ATM network only, and some customer would be using only frame relay services. So these are problems that the service provider could not solve very easily. They had to have one single access technology per VPN. Not only that, if you know that ATM as a technology always lagged behind IP technology, mostly because it is built around segmentation reassembly, and there is a severe penalty that you pay for that. As you know, ATM cells are all fixed 53 byte cells, so always cutting down the packets into that size and reassembling it, it's a very expensive operation, right? And then there was also not so much resiliency that you could build to the network because of the high concentration of circuits to the core. We saw what amount of provisioning need to happen whenever a new site is added to the VPN, right? And it's extremely labor intensive in the sense that the service provider needs to train a lot of people to understand how networks have to be built, and then teach them how to provision the circuits and things like that. So it's a very, very expensive operation to build not only the networks but also the workforce to understand and deploy the networks so that you can leverage the capabilities of the network. So next, so that is basically the motivation for building IPVPN.